So thank you for the introduction. My name is Donovan Brady. I am the Director of Solutions Architecture here at Logicworks. And as Ron mentioned, Logicworks is a premier AWS partner and a gold Azure partner and expert MSP. Basically, we're a cloud services provider who helps customers migrate, operate, and manage their infrastructures in the cloud. And again, as Ron mentioned, we are hiring the top talent. So if you are looking for some help managing or building a cloud environment, let us know. Without further ado, I'd like to talk about DevSecOps and how we can automate the management and operations of your infrastructure in the cloud. Now, I want to mention that this is an AWS-based presentation. It's going to be referencing a lot of AWS native services. However, all of the policies, best practices, and best practices are applicable to all clouds. This is not specifically for one. It's just overall best practices of how you should manage your infrastructure. So today I'll be talking a little bit about the overall principles of DevOps in the cloud, what that means and what we're trying to approach and solve for, and then actually what that looks like in a design. How does this look when we create the automation? What are we automating? And how does that help you in the long run? Then I want to talk a little bit about some customer case studies, and then a little bit specifically about that DevSecOps pipeline and what the automation can look like. So when you're migrating to the cloud, you are coming from an old world way of thinking where you're managing antiquated legacy systems, right? That's not the kind of world that we're in today's economy, right? Today's world, today's industry is all about fast, flexible, agile environments. The only way to actually manage a fast, flexible, and agile environment is to automate both your infrastructure and your operations. Most customers come to Logicworks and say they are looking for one of these four things. They want to modernize their applications and their platforms. They want to improve their security. You know, Logicworks specifically works with hyper-compliant PCI, HIPAA, high-trust companies in the fintech, SaaS, or healthcare, health tech environments. So they are all looking to meet one of these compliance standards. But when you have this large environment, you're migrating 1,000 VMs from your data center. How do you manage that compliance at scale? How do we actually maintain and achieve operational excellence? As you're about to hear in one of the following presentations from AWS, there is the well-architected 5 principles. One of the most important pillars in the well-architected framework is operational excellence. How do we keep 100% uptime? How do we manage this environment at scale? And finally, nobody wants to migrate to the cloud and find out that they're spending more money. So how do we optimize this and save money at scale? Well, the good news is automation and these DevOps principles aren't just specifically about security. They actually apply to all of these principles. The old way of doing things was really to throw money and people at problems. You know, you'd buy additional hardware, you're going to buy the biggest rack with terabytes of RAM, as much as you can possibly get, way over provisioned, and then you hire a bunch of engineers to manage that. In the cloud, you can actually automate that, decrease the number of engineers, decrease the number of infrastructure that you need to purchase, and then scale out as you see fit. There are 4 key principles for maintaining an automated DevOps pipeline in the cloud. 1, you need to design for constant change. Again, this is a flexible and agile environment. We aren't looking to build static data centers in the cloud. I have a saying. I say, if you're going to the cloud, then go to the cloud. You know, let's not just create a data center in the cloud. That's going to increase your costs. It's going to decrease your flexibility and limit your speed, you know, your time to revenue. You want to be able to utilize some of the great, amazing automation tools and services that AWS, Azure, and Google have created so that you can match that flexibility that you're trying to achieve. You know, how do you do that? By building repeatable components. You know, you want to be able to spin something up and tear it down in an instant. Then you spin it back up and it's the same infrastructure or something even improved. You know, the more that you create these snowflakes, the more that you create non-repeatable, non-scalable environments, the greater risk you have of failure, the greater risk you have of breaches. We'll get into that in a little bit. Thirdly, Amazon has a saying. They say, everything fails all the time, and it's 100% true. Everything fails. So you should anticipate that failure. And instead of trying to say, oh, well, I hope this won't fail, you say, I know this will fail, but how do I guard against that failure? And finally, human effort is basically security risk. It's all kinds of risks, but mostly security. You don't want anybody to fat finger anything. You don't want anybody to make a change that could open your ports to the world, give unencrypted access or something like that. So let's step into these one by one. Designing for constant change. We need to prepare for multiple different use cases. One, new environments. Let's say you're building a new application, or you're adding a new SDLC tier, or you want to give one of your SaaS customers a trial account, a trial environment, so that they can see if they like your product before you actually sell it to them. The only way to do that really at scale is with automation. You want to be able to spin this up as soon as possible. The customer asks, can I have that environment? Great, here it is the next day. We want to manage updates and infrastructure changes. If I want to make a change to the operating system of my virtual machine, or if I want to, like I said before, change ports or security groups or firewalls, I want to be able to do that at scale. If I have 100 different VPCs, I should be able to change all of them without having to go through manually each one in the console. We want to plan for that instance failure that I was talking about, and we want to ensure that our developers can deploy code in a fast and automated fashion. So stepping through each one of these, how do we plan for a new environment? Well, manually, that would be a slow process. Again, you'd have to deploy the VPCs, you'd have to define your route tables, you'd have to define your subnets, ports, access permissions for users, and then the infrastructure itself. If you're doing that manually in the console, if you had to do 3 of these, it's going to take you months. If you use an automated process, you can pre-build these templates, CloudFormation, Terraform templates, and bootstrap them with custom manifests using Puppet or Ansible or any one of these configuration management tools, so that any tools that you need can already be baked in. Some of these most important tools would be those security tools that you need for compliance. That would be PCI tools like threat detection, threat monitoring, file integrity monitoring, antivirus, and anti-malware. These are all usually agent-based processes that are going on your operating system. You don't want to have to manually deploy each of these because you could forget one. It's going to take a long time. You have no idea of maintaining or having visibility into which ones are actually deployed and which ones aren't. So if you prescribe this in a template and then just run the template every time, you know that whatever infrastructure is deployed is going to be whatever you defined in that code. Similarly, every instance that you have that you're managing is going to be following the same process. They're all going to have each of these updates. If we need to do some operating system updates or vulnerability update or installing these agents, as I just mentioned, all of those would be defined at that bootstrapping process. You don't have to go back and do it later. Every instance is going to have the same treatment because you're built off of that one known good. If you do have to make updates to your infrastructure, let's say you need to change your Etsy hosts file or something like that, if you're doing it one by one, using that same example from before, you have 1,000 different servers. Even if you had 100, 10, the more instances that you have that you need to change, the greater your risk of vulnerability, of failure, and of a security breach. Did we actually close the access? Did we log out of that Bastion host, or did we close that RDP session? Hard to tell when you're doing it manually. But if you're doing it in an automated DevOps fashion, you can roll back your code. You can actually maintain your ideal configuration because you can just blow away the infrastructure that's there and spin it up again. You make that one change to the code, and then your 10, 100, 1,000 instances all get that same infrastructure update. As you can see here, you can make multiple updates in the same day. One of my colleagues, Phil, as you can see here, made 4 updates to the same master branch in the same day, so that we can maintain that Git versioning, so that we can see these changes happened. Oh, if that actually was a bug, let's roll back, let's bring it back to this version, instead of having to impact your production workloads and have an outage for your customers. Let's anticipate failure. Again, in the old way, the manual way, you need to wait for an alert. The human must then take some remediation action, make sure that this is actually a real alert and not a false positive. You might have some downtime in there. You need to notify your customers. There's a lot of unnecessary processes. But if you're doing it in a DevOps world, it's going to scale out to an auto-scaling group instance, right? Oh, this instance isn't actually accessible. We're not able to route traffic to it. So let's go to the other one that is 100% live. You can have automation checks. You can have security checks. You can have availability checks that say this instance is running, this instance isn't. Let's automatically fail over traffic to the running instance. AWS and Azure and the other cloud platforms give you the tools for the high availability and for your security posture, but it is your responsibility to actually maintain it and to build that automation to support it. There's the old shared responsibility model. There are a number of graphs. I wish I had it in this presentation. There are a number of graphs online that you can see where AWS is taking care of the security and the availability of the underlying hardware, but then any software that you build, any applications that you're building, the EC2 instances or something that you're building into AWS is your responsibility. So the best way to manage this is to offload as much as that responsibility onto the automation tools or AWS as possible by using these native tools. We want to make sure that any automation that we use is actually working, right? So we have to test it. You want to do destructive testing and resiliency testing on your VPCs, on your infrastructure, on your auto-scaling groups, and make sure if one component goes down, it can come back up. If there's a breach and I have to lock down this instance or this account, then I can actually spin up a new environment just in time to have no outage or very, very minimal downtime. One great way of using this is chaos engineering. Netflix has a tool called Chaos Monkey that they came up with to basically go in the environment and rip everything apart and see how it actually stands up. How does this failure that was injected spin out a new automated instance? It's a great way to expose unexpected failure scenarios. If you thought you had accounted for 100% of failures or security breaches, then you might not have accounted for these 3. Finally, we want to make sure that the developers can deploy code to these environments. In a manual fashion, you have to log into the instance, log into the Bastion host, RDP, SSH, get all your configurations proper, deploy the code, test it, and then go to the next stage environment, and then UAT, and then production manually. That's probably a whole day's worth of work for that engineer. But if you're able to create a CI/CD pipeline with tools like Service Catalog or Code Pipeline, Code Build, you're able to create these tests and checks at each gateway in an automated fashion. It'll take a few minutes rather than a few hours. The process for that looks like a little something that you can see here. Let's take the example of an ECS cluster for some containerized environments. The Service Catalog is going to actually build out that infrastructure that builds the ECS clusters, and then GitLab is going to be our Git repo where we can both store our versions and also deploy the code in a CI/CD fashion, right? It pulls down that base image from Docker, builds the image, pushes the image over to AWS, and then puts it in the orchestration service that we just mentioned, ECS. That all should take about 3 minutes of time, and it has all the linting and security tests all built in, as well as those agents that we were talking about before, the intrusion detection, security protocols, antivirus and anti-malware, All of those policies would be in place at the instantiation of those servers. I've talked a little bit about this blowing away an infrastructure deployment and then spinning up a new one. Why is that? Well, it's because it's very expensive and time consuming to fix a server. Again, if you have 100 servers, you want to fix every one of them, that's going to take a long time. We have to troubleshoot, see what actually went wrong, turn off some services, restart some services, turn them back on. It's a lot. What happens when we just say, you know what, there's a failure there, let's turn it off and then spin it back up with the improvement. It's much faster, and it can work very well if you have those templates in place that we were talking about before. You can create these golden AMIs with an AMI pipeline, the Amazon machine image that is, that will be the base image for all EC2 instances that you want to roll out after that. That's going to include any agents that I was talking about before, user permissions or access permissions that you need at that operating system, libraries and modules for your application. You can bootstrap it with anything, patch that one instance, and then deploy that instance out however many times you need, rather than doing it each time manually in serial. Let's talk a little bit about a customer case study that we've done this for. So as I mentioned, we work with hyper-compliant customers. Many of them don't want their names to be out there. So let's talk about this enterprise backup software company. They host critical data for about 86% of the Fortune 500 enterprises. So obviously they had a high potential threat exposure. They came to Logicworks and wanted a way to repeatably create a SaaS model for these customers while maintaining security so that there would be no breaches for these large enterprises, right? So what did we do? We created this automated DevSecOps platform that I've been talking about. We created a CloudFormation template library that the service catalog can pull instances from, images. Wow, sorry. And then pull those templates and then redeploy them in any automated fashion, right? The environment can be blown away and rebuilt many times a day, however many times as possible or is necessary. Anytime you have a patch or an update to your code, you can just redeploy the infrastructure and it's going to have that newest update of your code. What did it result in? Well, it resulted in a 100% uptime for their production application. The instances almost never failed because they were being redeployed every few hours. And it was pretty much a single click deployment because with this CI/CD pipeline, you don't have to worry about going back into the instance and deploying your application and testing it. It's already all there with that automation tool in place. So I wanted to talk a little bit about the security impact of the automation and the DevSecOps tools that we were talking about and what that looks like in the real world. And then we can wrap up. You want to prevent your human error as much as possible. If you remember back to one of those first slides, human error equals a security risk, or human changes at all can probably equal a security risk. So we want to create controlled, standardized update processes, build processes, and make sure that there is little to no human intervention in your production environment. In your dev environment, that's completely fine. You know, we're developing applications. We should be able to change this whenever or however we want. But once it gets over to production, you don't want any of your customers getting impacted from a breach or a failure. Back to that concept of that immutable infrastructure and patching that one instance, you want to be able to create that golden AMI, patch that. You know, if there's a vulnerability at risk, create that AMI, patch it, save the new AMI, and then use that as the baseline for every new instance to be relaunched, you know. We also want to have some monitoring tools in place. Logicworks creates a lot of custom automation and scanners with our automated platform for management, right? Let's say there's a security group that is open to the world in this private subnet that you see right here, right? You could probably find that out if you were manually going through the console. There's only, 15 instances in this diagram, so you'd probably be able to see that. But what happens at scale? You know, if there are 4 VPCs with now 50 instances, it's much harder to see what security group is open on what instance, you know. So you want to have some automated tools, some automated scanners that if you open that port, if you open that route, then you get an alert automatically that says, hey, this is happening. You don't want this to happen. Do you want me to automatically remediate it? You know, you can create some automation using AWS's native tools and CloudWatch metrics to do just that. Additionally, you want to make sure that everything is encrypted at all times. Encrypt everything everywhere, wherever possible. That means your S3 buckets, your EBS volumes, your databases, whether that's SQL Server or RDS or Aurora or Dynamo. Usually it's just the click of a button in AWS. You don't have to pay for some encryption software from some third party anymore. You know, you just click encrypt my EBS volume, and then not only is that EBS volume encrypted, but also all of its backups and snapshots are as well. So really straightforward process, and probably one of the most important security automation tools you can deploy in your AWS environment. Some of the tools that we've talked about today would be the CloudFormation templates. You use those to deploy the infrastructure, make changes to your subnets, your security groups, your route tables, firewalls, things like that. I've mentioned Puppet and Ansible a few times. That would be a configuration management tool. That would be to change operating system level access permissions or user permissions or libraries or modules like that. And finally, encryption, again, that would be managed either via CloudFormation or Puppet, you know, depending on the tool. So to summarize, just wanted to go over, again, automation is really the only way to manage these infrastructures at scale in the cloud, and it makes it really easy with the native tools that AWS, Azure, and Google actually supply to you. CloudFormation is actually an AWS native tool. You know, it's just built right into the console. You can just build it. So you should always do it. However, you don't have to do it all right now. I've mentioned a lot today. I've mentioned CI/CD pipelines. I've mentioned immutable infrastructure with AMI, golden AMIs, Packer pipelines, encryption, scanners. It's a whole lot. Logicworks has been doing this now for about 12 years in the cloud. It's taken us 12 years to build the automation platform that we have today. You know, any step in the right direction is good. If you just get the CI/CD platform right now, great. You know, well, let's work together to move that forward over time. And finally, you don't want to have to worry about your infrastructure. That's probably not what your business is. You're a SaaS provider. You want to be able to create the code that's going to grow your company and help you make billions of dollars, right? The infrastructure isn't technically what's going to do that. So let us focus on your infrastructure and your DevOps. Again, Logicworks is a cloud services provider. We are an expert MSP in Azure and a gold partner, a premier partner in AWS with competencies in migration, financial services, healthcare, pretty much everything. We've got it. We're internally audited for HIPAA, HITRUST, PCI, SOC, ISO, GDPR. So if you're looking for some consulting work or some operation help, please reach out to us. My name is Donovan Brady, Director of Solutions Architecture at Logicworks. Thank you again.